In this video, we're going to work a problem where we are required to find the vector sum of forces. In particular, we are going to be getting these vector sums graphically. In most cases, you'll be working with a Cartesian coordinate system, so in either 2D or 3D, you sum vectors based on their components. But it's still valuable to work practice problems with vectors graphically. You learn a lot of the geometry involved in working with vectors, and it also gives you more of an intuitive feel for vectors. In this case, force vectors. So, okay, let's get started. Determine the magnitude and direction of the resultant. Fr is F1 plus F2 plus F3 of the three forces by first finding the resultant F prime, which is F2 plus F3, and then forming Fr is equal to F prime plus F1. So we're going to do a vector sum of these three forces, and we're going to do this graphically. So to work with vectors graphically, it helps to draw them to scale, at least their lengths relative to each other to scale. So let's start with F2, the smallest. So there's F2. All right, now F1 is 30, so F1 is 1.5 times the length of F2. So 1 plus a half, about right there. Okay, and then F3, so let's compare F3 to F1. 50 divided by 30, 1 2/3, okay. So 1 and then 2/3 of this, about right there. Let's draw the X and Y axes. Let's leave room for F3. Okay, so there's F3. Now F1. Okay, there's F1. All right, F2 is at this angle. Okay. And so this is 20, this is 50, this is 30, okay, and then it gives us that this angle is 20 degrees, and then it also gives us this slope triangle here, so we can find this angle. That would be, so arctangent of opposite over adjacent, 36.9 degrees. All right, so it wants us to first find this F prime, which is F2 plus F3. So this is F2 and this is F3. So let's use the parallelogram method. So we can draw a line from here parallel to F2, and then like that. So now we can draw the diagonal, and that is F prime. Okay, so now we need to solve for F prime. We're going to be using the law of sines and cosines to do this. So, okay, this is 50. This is 20. If we had this angle, we could solve for F prime. And can we get that angle? Yes, we can, because this is a 90-degree angle. So 180 minus 90 is 90, minus 20 is 70. This is 70 degrees. So now we can use the law of cosines to solve for f prime. So f prime is equal to a squared, so 20 squared plus b squared minus 2, 20 times 50 times cosine of 70. Okay? So 20 squared plus 50 squared minus 2 times 20 times 50 times cosine of 70 is that. Now let's take the square root of that. 47.1 newtons. Okay, so are there any other angles we can get right now? Well, let's do this. Let's go ahead and draw f prime plus f1. Okay, so let's do this. Let's move this here. That there. Let's erase this. So if we're going to draw a parallelogram between f prime and f1, it's going to be a skinny parallelogram. So let's draw this line. This is parallel to f1, about like that. And then let's draw this line that's parallel to f prime. Okay. Now let's connect this here. And that's FR. This is FR. All right. And then you've got an angle here and an angle here. Let's call this angle theta. Let's call this angle psi. And then let's call this entire angle beta. Okay, and we know that this is 30. And we know that this is f prime. All right, so now let's solve for FR. And then if we can get theta, then we will have the direction of FR. Okay, so let's start by getting beta. And we can see, so this is these two lines are parallel. This is a transversal. So this is beta. Okay, we can use the law of sines easily here because we've got f prime and these two sides. So sine of 70 over f prime, which we know f prime is 47.1, is equal to sine of beta over 20. Sine of beta is equal to 20 times sine of 70 divided by 47.1, 0.39902. So beta is equal to 23.5. Okay. Well, okay, we've got a lot of unknown angles here. We could say this. We know this 36.9, so we want to use that. That's part of the answer here because we're adding that to f prime. So let's extend this line. Okay. And then we can say that this angle is 36.9 degrees. And we've got another angle here. We'll call this gamma. And we can easily solve for gamma because, well, let's do this up here. Gamma is just 36.9 minus beta. So 13.4. So we've got gamma, beta. Okay, now next what we'll notice is these two lines are parallel, and here's a transversal, opposite interior angles. This is gamma. So we have these two sides and the angle between the two sides. We can use the law of cosines to get FR. So FR is equal to F prime is 47.1. Okay. 30 cosine of gamma. So 47.1 plus 30 squared minus 2 times okay. So 19.2. That's FR. So now we just need to find theta and then subtract 360 from theta and we'll have the angle. So we can use the law of sines again to get psi here. So we've got sine of gamma over FR is equal to sine of psi over 30. So sine of psi is equal to 0.362, 106. So psi is equal to 21.2 degrees. Okay, so now we can get theta because theta is equal to beta minus psi. Beta is 23.5. So theta is 2.3 degrees. And so we can say that from the positive x-axis, this FR is 360 minus 2.3 357.7. That's the direction of FR measured from the positive x-axis.